Hello, my name is Yohei Miyata. I am from Queen University, and I'm studying in mechanical engineering. Today, I explain to you about the mechanism of the atomic force microscope. We usually call it AFF from its initials. This picture is AFF used in my laboratory. The reason I chose this title is that I used AFF in my study, and it's a new technology. It was developed in 1985. You may think it's old, but in the field of the measurement device, it's comparatively young. Okay, I would like to start the explanation. First of all, you will have a question. It's what is AFF? AFF is a microscope used to observe the surface shape of the sample. Then, how is the surface shape measured? AFM is a needle called the cantilever. This is a picture of the cantilever. This is the size. It's so tiny. Next, please look at this illustration. Z-axis direction means height. Also, X or Y. X or Y direction means horizontal direction. In this way, as scan starts, the cantilever is bent like this. Scan means the cantilever goes over the sample surface, and then next, the axis is controlled to reduce this amount of the diffraction. This control value is measured at displacement, and it will be data of height, and it will become a surface shape. This is an illustration to explain in more detail the previous illustration. First, the laser spot reflected from the top of the cantilever is measured into the hot diode, and scan starts. When scan starts, stage to put sample is moved to the axis for contacting the cantilever. The cantilever changes the shape. This change makes optical path difference. And then the stage is controlled to reduce this difference to the axis with the scan. This control signal is measured as a surface state of the sample. This is the mechanism. Also, AFM has two types viewing mode. First, contact mode. It scans while putting the cantilever on the sample surface. And the other is non-contact mode, or mode called DFS mode. It scans sample surface while exciting the cantilever. Each characteristic is contact mode is suitable for a measure of a sample, which has a bump. Meanwhile, non-contact mode is suitable for a soft sample, which changes the shape when the cantilever touches it. It's a conclusion. The advantage of AFM is first, other measurement device such as scanning electrons microscope (SEM), which can only conductive materials, but AFM is possible to measure an insulation sample. Also, SEM needs a vacuum in the device, but AFM doesn't need it. Finally, AFM can measure in various environments. For example, high and low temperature in the liquid or in the air. I showed here example about using AFM. Left side, it's a optical microgram. As you see, it's a 2D display. And this side, on right side, it's a AFM image. Like this image, 3D display can be measured in more detail than 2D display. As I explained, AFM is easy to operate and it can measure in detail. So in future, AFM will be used more. This conclusion is my presentation. Thank you for your attention, and I'm happy to take your questions.